All right, so again, we're talking about the order of matrices, how to find an element in a matrix, and then how to add and subtract. That's what we're doing today. So a matrix is just a rectangular array of real numbers. Okay, and then when we talk about the order of a matrix, we're actually talking about the size of it. Okay, that's what order means, is the size. And we name it by the number of rows, by the number of columns. Okay, rows and columns. Which way did rows go? Left to right or up or down? They go left to right, yep. And then columns go up and down, okay? And then the way we write it looks like this. M by N, that little X is how you write your one thing by another. M is the number of rows, N is the number of columns, okay? And then you'll see I have three matrices down here. One's called A, one's called B, and one's called C. Those letters are just the names so that we can differentiate between which ones we are going to use. And we want to just first talk about the size. On the test, I'll ask you, what is the order of matrix A? Okay, it's the number of rows by the number of columns. Also, each little number in your matrix, like if we're looking at matrix A, the 2, the 6, the 8, the 4, the -2, and the 0, those are all called elements. Okay, so if I say what element is it, I'm talking about what's the actual number. Okay, so those individual numbers are called elements in your matrix. And what we want to do is we want to start off by looking at matrix A. We want to name the order of it. How many rows do I have? 2, okay. And then it's going to be by the number of columns. How many columns do I have? I have 3, right? So this is a 2 by 3 matrix, okay? When I say the order of matrix A, it's a 2 by 3. And if you'll notice, you have little like brackets, like square brackets there on the edges of your matrix. Make sure that you have little legs on them. Straight lines mean something completely different with matrices. So when you do it, make sure you do like the little square edges on it, okay? Because if you put straight lines, that means the determinant, which is something that we're not even actually going to have enough time to get to. So just make sure when you write it. Go ahead and write the order for B and write the order for C. Okay, rows by columns. Number of rows by the number of columns. So we already said that A was a 2 by 3. With B, how many rows do I have? 3, okay. And then if I'm looking at columns, how many columns do I have? 1, okay. So B has an order of 3 by 1. 3 rows by 1 column. And then if I'm looking at C, how many rows does C have? 2. And how many columns does it have? 2. Okay, so this is a 2 by 2. When your number of rows and your number of columns are the same, that is called a square matrix. Okay, that might be a question that you'll be asked. What is a square matrix? That is when your number of rows and your number of columns are the same. And then I just have the order written under those that we've already done. The order of A was a 2 by 3. The order of B was a 3 by 1. And the order of C is a 2 by 2. Or with a square matrix, since the number of rows and the number of columns are the same, you could also just call the order 2. Okay. And then just so that you're familiar, if you look down here, I have an A and then I have a little subscript. So it's the big capital A, that's which matrix I'm talking about. The little subscript is the order, a 2 by 3. So if they're going to tell you a matrix and tell you its size, they're going to put the capital letter of the name of that matrix, and then the subscript will be the order of it, how many rows by how many columns. Okay, so that's what all 3 of these are saying. Okay, So again, when you have a question on your test that says, what is the order of it? All I'm wanting is the size. How many rows by how many columns? Anybody have any questions on any of that? But just don't forget, rows are horizontal, columns are vertical. Got a couple people still writing, so I'm gonna wait just a couple minutes. Okay. A zero matrix, I'm going to give you a minute to write this down. A zero matrix is a matrix where all of your entries or all of your elements are zero, and the symbol is going to be a zero with a little bar over it. A zero matrix is just a matrix where all of your entries, all of the elements, all of the numbers inside your matrix are zero. And the symbol for that is going to be a little zero with a bar over it. That will probably be a question on your test as well. And what this is telling me, matrix A, right here, the letter A, tells me the name of it. And then this bit of information right here that I'm highlighting, the O with the bar over it and the subscript of 3 by 2, says that I want a matrix with 3 rows, 2 columns, and all of my entries are 0. And so that's what this is right here. That's what it would look like. You would have 3 rows of zeros and 2 columns. Okay, so we have matrix A, whose first row is 4, 6, and 2. Second row is -3, 0, and 1. And then we have matrix B, who only has 1 row, and that is 5, 2, and -1. So when you see a lowercase letter, that's telling you which matrix they're referring to, okay, instead of the capital. And then you have a subscript of 2 numbers. Those 2 numbers say that I want to know the element, the number that is in matrix A, row 2, column 3. Okay, what number is in matrix A in the second row and the third column? Think about this. Second row, third column, what number is there? 1. Okay, so the answer to that is 1. That's what I'm looking for when I have that lowercase letter with the 2 numbers next to it. It's what element is in matrix A, row 2, column 3. It's a number 1, so that's what your answer is 1. If it gives you one that doesn't have, like if it gives you one that's row 3 but you don't have a row 3, then you just say not possible. Okay, so go ahead and try 2 and 3. We want, for number 2, we want matrix A, row 1, column 3. And for 3, we want matrix A, row 3, column 2. What number is there? What number is in matrix A, row 1, column 3? 2, okay. And then for 3, which one is in row 3, column 2? Not possible. I don't have 3 rows in matrix A, so there is no element in that position because there is no third row. Is everybody okay with that? Now, it says below at the bottom, you can use a comma between the numbers to separate. Sometimes they do, sometimes they don't. It means exactly the same thing. We are still using those same 2 matrices. You don't have to write all that down, okay? It says you can use a comma between the numbers to separate. If the numbers of rows or columns is more than 1 digit, then you have to use a comma. So like if I had 12 rows, like that little example right here says, I would have to use a comma. But otherwise, if it's just a single number of rows or a single digit number of rows and a single digit number of columns, you don't have to use a comma, but they can also look like that. So using matrix B, I want you to find 4, 5, and 6 for me. Hold on, let me write matrix B. I'm going to write it right here. maybe. What is it, 5, 2, and -1? Was that right? Okay, so go ahead and find the element 4, 4, 5, and 6. What number is in what particular row, what particular column? What row are we looking at? For number 4, what row? Row 1, and then which column? 3, and what number is in row 1, column 3? -1. Okay. And then for number 5, we're looking at row 1, column 1. What number is there? 5. And then for 6, we're looking at row 2, column 1. What would you tell me for that one? Not possible. There is not a second row in B, so therefore we cannot give an element in a row that doesn't exist. Anybody have any questions? Pretty simple so far, right? Okay. That's why we end on matrices, because they're easy. All right. Then we are going to use, oh, just kidding, I'm getting ahead of myself. 2 new matrices. We're going to talk about finding the additive inverse of a matrix, which is basically just the opposite of every number in the matrix. That's what the additive inverse is. We have matrix A, we have matrix B. We're going to find the additive inverse of A, and it tells you what the symbol is. It's like just a negative in front of it. And finding the additive inverse is basically changing the sign of every element in that matrix, multiplying it all by a -1. The symbol for it is a -A. Whoops. So if I wanted the additive inverse of A, basically everything stays the same except for I change the signs of the numbers. So what would my first row look like for the additive inverse of A? -4, yep. And -6. Okay, I'm focusing on matrix A, and I'm basically just changing the sign of every element. What would the second row look like? 2 and -3. And that is your additive inverse of A. That's all you have to do. Rewrite it, change the sign of every element. Okay. All right, we did A already. Go ahead and do B real quick. Do the additive inverse of B. We did A, that goes right there. Additive inverse of B is what we're doing next. How do we know? Because it's got a negative in front of it. That's telling us do the additive inverse, or basically just the opposite of every number. Does 0 have an opposite? No. Okay, so that top one's going to say 0. And then 4 is going to turn to -4, and -6 is going to turn to +6. So that would be the additive inverse for B. Anybody have any questions? Alrighty. Now I think I'm ready to add. Yes. All right. So first of all, take a minute and write down all 4 of those. Okay. Matrices, that's plural for matrix, must be the same size to add or subtract. Okay, that means they have to have the same number of rows and the same number of columns. And my thing stopped writing, didn't it? Okay, it'll catch up hopefully in a minute. But matrices must be the same size in order to add and subtract. That's a little note that you need to make. And then it's about to go out now. Yep. Try this real quick, and if not, we'll just go to the board. Come on. All right. Give me just a second. All right, so again, to add A and B, they have to be the same size. Same number of rows, same number of columns, which they are. And then we just do one element at a time. First row, first column, we add. That gives us the number that goes in our first row, first column. Then we do the same thing. 2 plus 0 gives me 2. 6 plus -2 gives me 4. And then -2 plus 1 gives me -1. 0 plus 5 gives me 5. Oops. And then 1 plus -7 gives me -6. Okay, so that's the answer for the first one. Number 2, C and D, are they the same size? Okay, so if I add them together, what's 4 plus 5? 9. And then 0 plus 0 is 0. Hey, your purse? Give me just a second. -8 plus 2 is -6, and 1 plus -6 is -5. Did everybody get 9, 0, -6, -5 there? All right, what about 3, A plus C? Not possible. They're not the same size, which means we cannot add them together. So you just put NT for that. Not possible. Okay, that one is not possible again because they are not the same size. We're going to use the same 4 matrices, and this time we want to subtract. Subtraction is the same. Just be careful what the order is. If it's C first, then you need to look at C first. But you still just subtract the same elements. First row, first column, first row, first column. I usually like to write them when I do subtraction. I'm not telling you you have to. Come up here. But I would write matrix C first just so that I have it right next to me, which is 4, 0, -8, and 1. And then minus matrix D, which is 5, 0, 2, -6. And then we do exactly the same thing we did with the adding. We're going to go 4 minus 5. What's 4 minus 5 give us? -1. Okay. And then we're going to go 0 minus 0, which is 0. And then we're going to go -8 minus 2. -8 minus 2. -10. And then 1 minus -6. Oh, I can't see this. Try that again. 1 minus a -6 turns into +7. So the answer to C minus D is going to be -1, 0, -10, 7. If you will, go ahead and do 5 and 6, subtracting those. I'm just going to write it down for 5 and 6 because since I can't see them on this screen. Keep going though, we won't go over the answers just yet. Working on 5 and 6. Doing A minus B and then B minus C. Remember, if they are not the same size, it cannot be done, and so you just put not possible. Is 5 possible? Are A and B the same size? Okay. So we're going to go 4 minus 3, which gives me 1, 2 minus 0, which is 2. 6 minus a negative 2 gives me 8. Negative 2 minus 1 gives me negative 3. 0 minus 5 gives me negative 5. And 1 minus a negative 7 gives me another positive 8. So the solution to A minus B, row 1 is 1, 2, and 8. Row 2 is negative 3, negative 5, and 8. Good news is when we do these on our test, if you miss one number in this matrix, I'm not counting the whole thing wrong. I'm just going to take a point off. There's a lot of partial credit that I can give here because some of them have so many elements to them. I'm not going to count it wrong if you just miss one. Okay, so that is the good news. You get a lot of partial credit. What about number 6, B minus C? Not possible. They are not the same size. Cannot happen. I think that's probably about it, but let me just double check. Oh, let's do one of these. Same matrices, so you don't need to write them again, but we need to just talk about what it looks like with our 0 matrix. Okay, so you don't need to write those matrices again. You already have them written down. They're the same ones we wrote the first time. But for number 7, it says D plus a 0 matrix, and that subscript is a 2, so that means it's a, what size? If it just says 2. 2 rows, 2 columns, a 2 by 2, right? So the first thing we have to check is D a 2 by 2? Yes. So essentially, what that looks like, and not that you need to always write this down, but I'm just trying to show you. D is 5, 0 to negative 6. And that's just saying we want to add a 0 matrix with 2 rows of zeros and 2 columns of zeros. They are the same size, so they can add together. And if I add 0 to anything, does it change it? No. So the answer is going to be exactly like D is 5, 0 to negative 6. And then 8 says we want to take B and add a 3 by 2 matrix or 0 matrix to it. What size is B? It's a 2 by 3. And they want us to add a 3 by 2. Can I add a 2 by 3 and a 3 by 2? No. Not the same size, so therefore it's not possible. Okay, because B is a 2 by 3. That 0 matrix is a 3 by 2. Those are not exactly the same size. They are reversed, which means they cannot be added. So therefore, that is all we can do with those.